Well, that's a KFOG. Key features of graphs. I'm not writing that out every time. So today, you're going to have a worksheet. Tomorrow's a worksheet. Wednesday's a worksheet. Thursday's a worksheet. Friday's a quiz. Monday, Tuesday, Wednesday, you're going to have different worksheets that talk about different key features of graphs. We'll put it all together on Thursday, and then you'll have a quiz on Friday. Now, remember, I am gone on Wednesday. You will have a sub. No, I don't know who it is, and I don't really care your opinion of who it is. Okay, I will record a video, and you'll watch a video. They're not teaching anything. Okay, it'll be like I'm here. You guys will just watch a video and take notes with me. Volleyball, I understand that you're going to miss class on Thursday, correct? Okay, I will make sure by tomorrow I have Thursday's practice worksheet done so you can be prepared for your quiz on Friday. All right? You don't need a calculator at all this week. It is pure, I'm going to tell you right now, it's a lot of terminology. It's a lot of what does this word mean and how do I identify it on a graph. Okay? If you want highlighters, you can have highlighters. They're not essential, but if it's something you get into, you totally can. Here we go. If you can identify, chill out, guys. Stop paging. They get longer as the week goes. There's like 5 questions for homework. You're fine. Okay? A lot of this has to do with vocab. All right? We have 3 different types of functions. We can have a discrete function, we can have a continuous function, and we can have one that's neither discrete nor continuous. A discrete function are just random points on your graph. They are not connected. Continuous functions are points connected to form a line or a curve. I always say, could you take a Matchbox car and drive it along that road? If we took a Matchbox car, this technically could be a road. Yes? Your car wouldn't fall. If it's neither discrete or continuous, it means that points are connected, some of them by a line, maybe by a curve, but it's not continuous. If I went to drive a Matchbox car, we have an issue right here in the middle, correct? Some of those problems that we had yesterday or last week about function or not a function, if they were 2 staggered lines, if you can't smooth drive a Matchbox car on it, then it's probably going to fall into neither discrete nor continuous. The bargain book, that's supposed to say barn, typo. The bargain book, Bark, sells young adult novels on a sliding scale. That is, the more books you buy, the cheaper they are. Let f of x is just a fancy way of saying the equation or the function, model the store's prices for a given number of quantities. Is f of x discrete or continuous, and explain. Discrete and continuous, you're really looking at your x values. On discrete functions, it means that only whole numbers for x value, for your x values. That it wouldn't make sense to have a decimal x value. On continuous functions, you could have whole numbers and decimals for the x. Now, on our examples for discrete versus continuous, we don't have labels on our x, but most of the time we're going to have labels. So in the book, Bargain Book Barn, what is the label on my x value? Your number of books. So we ask ourselves, discrete means we can only have whole numbers for our x value. Continuous means we could have decimals or whole numbers. Is the Bargain Book Barn discrete or continuous? Why? What does X stand for? Number of books. So you guys are telling me I can buy 0.25 of a book? No. Only whole numbers would make sense for your X value. So this would have to be a discrete function. You're not going to plug in 1.5. You're not going to buy 1.5 books. Our X value, the number of books, can only be whole numbers. f of x is discrete. When we would draw this graph, it technically would just be points. You can buy 1 book, you can buy 2 books, you can buy 3 books, you can't buy 4.5 books. If you would connect the dots with a line, you're telling me that every single number in between 4 and 5 works. And we know that is not the case. So when you're trying to determine this, look at your labels. Labels on your x's. I don't care about my y values. It has nothing to do with my y values. My y values are decimal, whoop-de-doo. Okay? All right, so now we need to determine if f of x and g of x are continuous, discrete, or neither, and explain. So if we look at A, f of x graph. F of x is graphed with a, what shape is that? Curve, very good. F of x is graphed with a curve, meaning it is a continuous function. You could drive a Matchbox car along that graph. G of x. G of x has separate, I would take that, separate sections but is not a single line or curve, meaning it is neither discrete nor continuous. Now, on your quiz, I'm not going to have you fill in the blank guessing this. This is just easing us into what things that you're looking at. It's going to be more like example C. Is P of x discrete, continuous, or neither? How do you know? They are not connected. It is discrete. It is not connected by a line nor curve. Not connected by a line nor a curve. Really, on this g of x, I had the word multiple. Separate makes sense too, but it has multiple sections or separate chunks. Okay, so discrete or continuous, you're looking at the shape, or possibly if you're given a table, you're looking at what does my x stand for? Would it make sense for me to have a decimal or a partial of an x? Okay, now this next part you know. The intercepts of graphs are points where the graphs intercept an axis. We've done this, right? So you can fill this in with me pretty easily. The x-intercept is the x-coordinate. The x-coordinate of a point where the graph crosses the x-axis. The y-intercept is the y-coordinate. Was that a sneeze? Bless you, I think. Where the graph crosses the y-coordinate. Now a new piece. The function is positive when the graph lies above the x-axis because your y values are positive. A function is negative when the graph lies below the x-axis. Now your x-intercept is going to determine that, yes? At the x-intercept, it's going to either switch from positive to negative or negative to positive. So here's an example. Use the graph to estimate the x and y intercepts of the function and describe where it's positive or negative. The x-intercept is the point where the graph crosses the x-axis, which would be where? 3, 0. Everybody agree this is our x-intercept? Yes? The y-intercept is the point where the graph crosses the y-axis. 0, I think 6, right? Here. You're like, I hope we have lots of these, right? Okay. A function is positive when the graph lies above the x-axis. Whenever you tell me positive or negative, you may want to make a note here. Use the x values to tell location. And I'll show you what I mean here in a minute. You're going to use your x values because the x value is where you swap. Everybody agree at my x-intercept, my graph switches from its location, correct? To the left, over here, all of this piece of the graph is above or below the x-axis? Above, meaning it is positive or negative? Positive. So this side of the graph is positive. This side of the graph is negative because it's below the x-axis. So you have to give me a location. A function is positive when the graph lies above the x-axis. In this case, when x is less than 3. Right here, x is 3, correct? When x is less than 3, is that to the left or to the right? To the left. So I'm telling you, everything to the left is above the x-axis. The function is negative when its graph lies below the x-axis or when x is greater than 3. So you're giving me the x value of where this changes. Where does it go from positive to negative? Now, this number should always be your x-intercept. A function will not swap from positive to negative unless an x-intercept occurs. Follow me on that? So if you tell me the x-intercept was at 4, 0, you better have 4s here, yes? All right. Use the graph to estimate the x and y intercepts of the function and describe where the function is positive and negative. See if you can fill this in for me. Question?
On the last slide, what is it if it's right on the...
It is neither positive or negative. That's why we don't use equal to, we just say less than and greater than. Good question. See if you can fill this in. The bottom one just put 2 numbers in there. This is just 2 numbers. Who can raise their hand and give me one of my x-intercepts? Thatcher.
3.
Ordered pair.
0.
3, 0. Mason, what's my other one? Negative 4, 0. Who can tell me my y-intercept? Morgan. 0, 0, negative 12. Who can tell me positive when, Sophia? X is, ooh, careful. Greater than negative 4 would be this direction. So x is less than negative 4. And when x is greater than 3. Okay? The way I look at this, x is less than 4, that goes this way. That means this whole section is going to be positive. X is greater than 3 would mean this whole section is going to be positive. Yes? Okay? Negative, when x is between -4 and 3. From -4 to 3, where is your graph? Below the x-axis. Guys, positive and negative, you're always referencing x values. You're always referencing x values. It's like the battleship, it is the location. I'm telling you, go to x equals 3 and it's going to swap from either positive to negative or negative to positive. Okay? Do another one. The graph shows the height of the ball for each second x that it's airborne. So if we take a second to look at our graph, time is on the bottom in seconds, and height is on the y in feet. Okay? Use the graph to estimate the x and y intercepts of the function, where the function is positive and negative, and then interpret it. So these are the blanks we're going to fill in. I'm going to give you a second to try to fill these in before I start asking questions. The x-intercept is blank. It means the ball will hit the ground after blank seconds. The y-intercept is blank. This means at the time blank, the ball was, gosh, who should proofread this? Was at a height of blank. It's positive when x is between blank and blank, which means the ball is in the air for blank seconds. No portion of the graph shows the function is blank. See what you can fill in. Who can tell me the x-intercept? The x-intercept is at 9, 0. Thoughts? 9, 0. That means the ball will hit the ground after 9 seconds, okay? Because x is seconds, y is height. So 9 seconds, height of 0, meaning it's on the ground. The y-intercept is 0, 4. This means that at time 0, the ball was at a height of 4 feet. What does time 0 mean? 0 seconds. What does that mean then? Okay. How could a ball already be in the air? Savannah? Yeah, when you guys throw a ball, you don't throw it from the ground, right? Unless you're playing football. Yes? But if you're playing catch with somebody and they're going to graph it, the ball isn't starting on the ground. So whoever has the ball in their hand was at 4 feet tall. Yes? Their hand was when they started it. The function is positive, meaning above the x-axis between 0 and 9, which means the ball is in the air for 9 seconds. No portion of the graph shows that the function is negative. Now, I know right away some of you are going to go, but Ms. Hoff, really this could continue down, yes? Oh, so you threw the ball and it went into the ground? That'd be a negative distance, right? Or if you go over here, that was before you, like back in time, before time 0. So that's why it's the statement of no portion of the graph. So what they showed us here, it does not make sense for us. Notice there's not arrows on the end of it, correct? So they're telling you really this is restrained by time 0 and height 0. Getting better? It just takes practice with this. Okay, so the graph shows the number of people, Y, at a gym X hours after the gym opens. Let's just look at this. Gym occupancy. What's occupancy mean? How many people are there? So like at a certain time they stopped and said like, this many people. Okay? So time 0 all the way to time 12, and then their graph goes from 0 to 200 a number of people. Right now, only do part A. Use the graph to estimate your x and y intercepts. Label them. Which one's your x-intercept? Which one's your y-intercept? Only do part A. Somebody who has not answered for me, give me your x-intercept. Say it again. 12, 0. Love it. Somebody else who has not answered, give me your y-intercept. Very good with that scale, 0, 20. Sometimes we always catch ourselves off guard. Okay. Now, reminding yourself, x is time in hours, y is number of people. I want you to tell me what the x-intercept means. I want everybody to think. X is time, y is the number of people. Jackson, what do you think?
12 o'clock.
Oh, they got mad at you right away.
No, it starts at 0.
I know, but it's not a 0. It's 12.
So what are you going to fix on it?
I would say that's how many hours they're open.
I would say that's how many hours they were open. The graph shows the number of people at a gym hours after the gym opens. How long was the gym open? 12 hours. What happened at 12 hours? It closed, but what do you know? Sorry, I shouldn't say what happened. How many people are there? Very good. The gym was open 12 hours. At that time, there were 0 people inside. I guess maybe it didn't necessarily close, but after 12 hours of being open, there were nobody in that gym. Okay, I'm going to give you a second to think on the y-intercept. Your y-intercept is 0, 20, reminding you that x is time in hours and y is your number of people. What you got for me?
20 people are there when the gym opens.
Very good. And you know it's the gym open because it says the hours after the gym opens. Well, it's 0 hours of it being open. It's just opening. So there, oh, I should maybe look like that has an R in there. There were 20 people at the gym when it opened. Once you write that, set your pencil down. So all of you that were flipping through this going, this thing's like 6 pages long. Well, we just did 4 pages of it, right? 3 pages of it. 3 pages of it? 4 pages of it. 3 pages of it. And that was just notes. Okay? Oh, just kidding. We're not done yet. I thought I was at the homework. Just kidding. Go back. Grab your pencil. Flip it over. Violet. God, TikTok gets in my head with Violet. You know those that, never mind, there's a thing on TikTok about Violet. Drives me. I don't have it, but I watch it. You can't be on my social media, so
Wait, really?
it's my contract.
Yeah.
If it's educational,
It's not.
It's not.
No.
No, I know what you're saying.
you are not to be, okay. Stop. I just asked you to quit. You don't want to be on my social media because you don't want me in yours. Agreed?
Agreed.
Yeah. Don't be on my social media. I'm pretty lame anyway. All right. Violet starts this semester with $150 in her student lunch account. Each day she spends $3.75 on lunch. The table shows the function relating the amount of money. Wow, the typos in here are atrocious. Remaining in her lunch account to the number of days Violet has purchased lunch. Just an FYI, I read through this thinking I caught all the mistakes. I think I was sleeping. So they give me the table. Find the intercepts. How do I do that without a graph? The x-intercept is where y equals 0. So if we look at our graph, the x-intercept is at 40. The y-intercept is where x equals 0. So the y-intercept is 150 or 150. Okay, so as a reminder, x is our days, y is the balance, meaning how much money is remaining. The x-intercept means that after buying lunch for 0 days, no, the x-intercept, 40 days, Violet will have 0 left in her lunch account. Or in other words, it will take Violet 40 days to use all of the money in her lunch account. The y-intercept means that Violet's lunch account has $150 after buying lunch for 0 days. Or the beginning balance of her lunch account is 150. If I didn't give you these blanks to fill in, I would say something like, if you just said to me like, Violet started with $150 in her account. It took Violet 40 days to spend all of her money. I would know you were talking about her intercepts. Okay, now we're to the beautiful thing of homework. Make sure you read the directions. These do ask you to explain on 1, 2, 3, 4, 5, 6 are the same. 7, I start to ask you questions. X and Y intercepts, positive and negative, and then I start asking you about the intercepts and the context of the situation. Okay? Questions? 972. 972 is my favorite number. All right, go to work. What do I have?